This is an electrical wiring diagram tutorial, a full walkthrough that takes you from a blank page to a finished, simulated wiring diagram, all in a free browser tab. No install, no sign up, nothing to buy. By the end, you will know what a wiring diagram actually is, the handful of symbols that make up almost every one, how to place them, how to wire them, how to label them, and the part most guides skip, how to prove the circuit works before you ever touch a real wire. We will build a real example together, step by step. On screen right now is where we are headed. Let's start from zero. First, the idea. A wiring diagram is a map of how electricity flows through a circuit, which component connects to which, and in what order. It is not a picture of what the thing looks like, and it is not a floor plan of where the parts sit on a wall. That's actually a common mix-up worth clearing up. A pictorial diagram tries to look like the real hardware. A schematic, which is what we're making, throws that away and shows only the electrical connections using standard symbols. Same circuit, but the schematic is the one you can actually reason about because it strips out everything that isn't the electrical story. And that story is simple. Power leaves a source, runs through switches and devices, and returns to where it started. Electricity only does work when it can make that complete loop. If you can read that path, out from the source, through the loads and back, you can wire the real thing without guessing. Every wiring diagram, no matter how complex, is built from just three things. Symbols, the standard shapes that stand in for real parts, like a switch or a light. Wires, the lines that connect them, carrying power from one to the next. And labels and values, the notes that say what each part is and how big it is, like a 15-amp breaker or a 60-watt bulb. Learn those three, and every diagram in the world opens up. A giant industrial control panel is just more of the same three ingredients. So let's meet the symbols. This is the free tool we will build in, an editor that runs in a plain browser tab. Down the left is the symbol library, and it is electrical from the very first click. Here are the ones you will use constantly. A power source or a battery, where the electricity comes from. A circuit breaker, the safety switch that cuts power if something draws too much current. A single pole switch, the everyday light switch, on or off. A three-way switch, the one that controls a single light from two places like the top and bottom of a staircase. A light fixture, the lamp or bulb, the load that actually uses the power. An outlet, where you plug things in, and a GFCI outlet, the special one for kitchens, bathrooms, and anywhere near water. A fuse, a resistor for electronics work, and ground, the safety return path, the symbol nearly every circuit needs. Notice that each symbol is deliberately abstract. The switch symbol is just a line that breaks a connection. It doesn't matter what the physical switch looks like, the meaning is the same everywhere in the world. That's the power of standard symbols, their shared language. An electrician in one country can read a diagram drawn in another. You do not have to memorize all of them today. Just recognize that each shape means one specific thing, and that the library has a search box at the top, so you can always find a symbol by name, type breaker, and there it is. That is the whole alphabet. Now let's write with it. A quick tour of the workspace before we build, so nothing feels mysterious. The big area in the middle is the canvas. That's where your diagram lives. The left panel is the symbol library we just met, with the search box at the top. Along the top is the toolbar, undo and redo, zoom, and the buttons for the two things we care about most. Simulate, which runs the circuit, and export, which gets your drawing out. Placing a part is 2 clicks. Click the symbol in the library, then click the canvas, and it snaps neatly to the grid. To wire 2 parts, you click one connection point and drag to another. That's the entire interaction. Click to place, drag to wire. Everything else is just tidying up. Now we build. Our example is the most common circuit in any home, a switched lighting circuit. Power comes in through a breaker, runs to a switch, the switch feeds a light, and everything ties back to ground. Step 1. Place the breaker. Click the breaker symbol, click the canvas, and there it is. Step 2. The switch to the right of the breaker. Step 3. The light fixture further along. In Step 4, a ground symbol underneath for the return path. For parts, placed in seconds. Notice they snap to the grid, so they line up on their own. No fiddling to get things straight. This is the same starting point you'd get from a template, except you built it yourself, so you understand every piece. That understanding is the whole point of drawing the diagram instead of just copying one. Parts placed, now we wire them. And this is where a diagram becomes a real circuit. Every symbol has connection points, little nodes where wires attach. Click a connection point on the breaker and drag to the switch. The tool routes the wire for you with clean right angles. No wobbly freehand lines to straighten later. Now wire the switch to the light, and finally the light back to ground. Follow the power the whole way. In through the breaker, through the switch, to the light, home to ground. That closed loop is the circuit. If any link in that chain is missing, the loop is broken and nothing lights up, which is exactly the kind of mistake we'll catch in a minute. Here's the payoff of wiring it properly instead of just drawing lines. The connections are live. The tool knows the switch is genuinely connected to the light, not just sitting near it. Drag a component, and every wire attached to it follows and reroutes on its own. Move the whole thing around, and the drawing stays tidy. In a plain drawing tool, you'd be chasing lines by hand every time you nudged a part. Here, the wiring keeps up with you. Last, make it readable, because a diagram nobody can follow is useless. Label each part and add its value. The breaker's amp rating, the light's wattage, the wire gauge, if it matters. Give the switch a name so you know which one it is. A diagram someone else can actually build from, or that you can come back to in 6 months, is one where every part is named and rated. That's the whole difference between a rough sketch and a real wiring diagram you can trust. Now the step that sets this apart from a plain drawing, we simulate to prove it works. There's a real spice engine built into the page. The same kind of simulation math that professional electronics tools use. Open Simulate, choose DC operating point, and hit Run. Live voltages and currents appear right on the diagram. Real numbers computed from the exact wiring you drew, not a canned animation. You can watch the voltage at each point and the current flowing in each branch in real units, volts and milliamps. This is your safety check, and it's the step that turns a drawing into something you can trust. If a wire is wrong or a connection is missing, the numbers say so. A 0 where you expected voltage means the power simply isn't getting through that path. You catch the mistake here, on screen, in seconds, for free, instead of at the wall with a multimeter, or worse, after something's already smoked. Think about that. You can test the circuit before a single real component exists. If you need more, Transient shows how the circuit behaves over time, and AC sweep tests it across frequencies, both live in the same dialog. But for most everyday wiring, that single DC operating point run is all it takes to know your diagram is sound. The diagram is drawn, wired, labeled, and verified. Last step, get out of the browser. Open the export menu. PNG is free, so you can drop the image straight into a document, a message, or a printout. On the free plan, it carries a small watermark. The vector formats, SVG, PDF, and DXF for CD, sit on the paid plan. I'd rather tell you that plainly than have you hunt for it. You can also share a live link to the diagram, so someone else opens the exact same working circuit in their own browser. Nothing to install on their end either. For most home, auto, and hobby wiring, that free PNG is genuinely all you need. So that's the full loop, symbols, placement, wiring, labels, simulation, export. You just took a blank page all the way to a finished, verified wiring diagram. Where to go from here? You don't always have to start empty. The tool has a library of ready-made diagrams and templates you can open and study, from house wiring to car circuits to control panels.